Okay, so what I would add to my handout that I didn't think to add yesterday, when are we going to know to use this in a problem? I mean, it's a cute acronym. So when are we going to know to use this? So we're specifically going to look for keywords. If they ask you to describe the graph, which we tend to call our graphs distributions, if they ask you to describe the distribution, or if they ask you to compare distributions, that's when you know you're supposed to case. So I'm supposed to case when I'm describing or comparing distributions. Okay. Inside we talked with center. We had discussed the mean, median, mode, and I swear we're going to get some more practice to that. I swear we're going to practice all the things. I just wanted you to know, cuss, before we got any further in life. And then so there's nothing new I want to add to the C. There is something new I want to add with unique features that I don't know why it left my brain yesterday. Yes, everyone knows the word outliers. Of course, your graph might have an outlier. In statistics, we're actually going to prove it with a formula that that's an outlier. And if for some reason you forget the formula or you just can't, or you use the formula and it doesn't work or whatever, you can always call it an influential point. You can say it was important. It just wasn't an outlier. Okay, but another thing that we should talk about that I didn't add to unusual features yesterday is a gap. What's a gap in life? Like a giant hole or a space. You're going to know when there's a gap. And then, of course, there could be a cluster. A bunch of data points set in one spot. Like us with our M&Ms the other day. There was a cluster. Okay, and then words I should have said yesterday and I will say today. When you want to claim something's an outlier, because I, like you, I love me an outlier. I love to be like, that is an outlier. In AP Stats, we like to say why we think it's an outlier. So you say it's an outlier, you're going to prove it with this formula we're going to get to shortly, and then you might want to hypothesize why it's an outlier. Like, for instance, we didn't have an even distribution of M&Ms. Like if we talked about how they could be all green for St. Patrick's Day. Like, so there might be a reason why there's an outlier with your data. And it's not a bad idea to hypothesize about it, but you need to consider your context. Can I not spell today? Context. Consider context. I meant context. So, like, the actual situation given. So back to us and the M&Ms, if we had a lot of greens, maybe I would hypothesize something about a holiday or an event. Context. Okay, so we talked briefly about U. We're going back over U. The first S was for shape. So we mean the shape of our graph, the shape of our distribution. We talked about symmetric, uniform, skewed left, and skewed right. And just as a general reminder, it's the opposite of what you think. Skewed left actually means the tail is to the left. Skewed right actually means the tail is to the right, which to me is counterintuitive. If I could go back and rename things, I would, but I do not get to. Yet. I'm not that cool. Okay, and then yesterday for the other S, we talked about spread, and for the love, I know y'all know how to do range. I got that. But we're going to do more than just range, and I thought maybe we should list the things. Oh, gosh, don't die. I thought maybe we should list the things we're eventually going to be cool enough to do. We're going to do range, IQR, which stands for interquartile range. We'll get to that today. And then, of course, we'll do standard deviation. The cool thing about a lot of this, the mean, median, mode, range, standard deviation, all the things, is that eventually we're going to be cool enough where we type it into a list, we press a magic button on our calculator, and our calculator does all the calculations for us. If we can read it from the calculator, it's going to tell us the mean, the median, it's going to tell us the range, it's going to tell us the IQ, it's going to tell us all the things. We just have to ask it nicely and know what each letter means. Okay, and then to not scare you, and you don't have to write this, but just if you're stressed because you're like, I don't know what on earth she's talking about, I swear it's all going to keep popping up, and we're going to learn more about all the things as we continue throughout this course. All the things. Okay, so I'm going to put a timer, because if I don't put a timer, I'll let you work all day, and we'll never actually get to notes, which we need to. I'm going to put a timer of 20 minutes, so you and your group can work for 20 minutes. I don't care if y'all use similar words, But you're your own person, so you have your own paper. The problems you don't finish with your group, that would be what I expect you to finish for homework. I will actually grade it tomorrow because you would have it already. And if you didn't finish your data collection activity, you need to get that to me as soon as possible too, because that can be a grade. I'm going to grade whether or not you got categorical or quantitative, and I didn't do your notes.
No, we got it.
Okay, cool.
I just got to see if I can have something like
Go for it. I meant to.
I think it's going to be more every one, works. I mean, 1, 3, 1, same thing. I read the back.
Numbers.
Read those.
Okay, we're going to go back to your notes now because Olivia just asked a good question. I don't know if your group, you need to finish that and turn it in. If you've already got it done, turn it on your way out. Olivia asked a good question about number 4. She noticed that the graph looked, you might have to put your paper on the screen. She noticed that the graph had these double humps, and she wanted to know if there was a term for that, and there is, which is why we're getting back to the notes today. For now, I told her a gap was sufficient. By the end of class today, she'll know an actual word to put with that. Okay, so our little shape thing from yesterday with CUS was great. However, there's more than just skewed left, skewed right, and symmetric. So we've got to talk about the other kinds of graphs. So very quickly, we'll go back over symmetric. Mine doesn't always look pretty. How would you describe that?
Symmetrical.
Yes, I know you describe it as symmetrical.
One hump.
It's one hump, and that's why most people call it mound shaped.
LOL.
Mound shaped. And then you already know skewed right actually means the tail is to the right, so the majority of data points are happening to the left. So if this was, let's say, 0, 50, 100, most of the data points are actually happening to the left. And then skewed left, the tail is to the left. 0, 50, 100. And then you should have already known those. Now we finally get to the new one of unimodal. The unimodal, I'm actually going to represent it with a type of graph we discussed yesterday.
Histogram?
No, good guess.
Dot distribution.
8. 1, 2, 3, 4.
Yeah, I see.
Okay, so I did it with a dot plot. And I think you can already tell why it's called unimodal. Why is it called unimodal?
So there's one really big column.
So we're going to call it one major peak.
LOL.
Now, I love what Sally was doing on her paper. You don't have to do it on your paper. I get you see things in your head. But on her paper, she was automatically, no matter what kind of graph it was, she was applying that curve on top of the graph. I think that's smart. Okay, if unimodal meant one major peak, what is bimodal going to mean?
2 major peaks.
Of course. So I believe the question that Olivia was asking me about is going to be a bimodal because it had 2 peaks. But, you know, maybe they have 1, 2, 3, 4, 5, 6, 7. 1, 2. Clearly here on my fake graph, both 2 and 5 are very high. So we call it bimodal because of those 2 high points, 2 major peaks.
Those are twin peaks.
They are, I think I did 6 with one and 5 with the other. They don't have to be exactly twins. As long as they're substantially higher than their friends, then we're going to consider it bimodal. We would love, if we could, in AP Stats, to make every single thing symmetric, but that's not always the case. All the good things in life are symmetric, but that's not always the case. Well, we're eventually going to learn if you have enough data points that everything becomes symmetric, but That's to come. Okay, and then uniform we did discuss yesterday, but I think I drew my graph a little too pretty yesterday, so I'm going to draw a histogram. Why do I know that this is a histogram and not... Okay, exactly. Okay, so they're not exactly all even, but they're pretty even. They're not drastically different. They're all about the same frequency. And if they all look, they're all about the same frequency. There's not one that's substantially standing out the way they were substantially standing out with unimodal and bimodal. Then we're going to call it uniform. Okay, and now we get to back to the center. So I don't know why the notes went out of order with cuss while we're on shape and then go back to center. Don't they know how to cuss? Okay, so with the center, I know you already know a lot of these things, but you don't know that the letters we're going to use, or maybe you do. So you already know how to calculate the mean is the average. You had to do that yesterday, so now you know how to do it. The only issue that I want to point out today is that it depends on the sample. If our sample is of M&Ms, then it's going to be called X bar. If our sample is of people, it's going to be called mu. The Greek letter looks kind of like a U. I just do my U and I make it curly. That's sufficient. And then X bar, seriously, is an X with a bar on top. And we actually discussed this yesterday, but it does not hurt to be reminded. You need to be careful with the mean, because with extreme cases, like remember yesterday with our cuss handout, how once we changed that 20 to a 50, it drastically changed our mean. In the same way, any outliers or really any big points are going to affect the mean, and so the mean is not a resistant measure. Okay, so if it's not resistant, and so if there are a lot of points one way or another, we don't want to use the mean. So do you want to use the mean if it's skewed left or right?
No.
No, you would only want to use it if it's symmetric. Okay, if your graph is skewed left or skewed right, and there's nothing you can do about it, you're going to use the median. It is the middle. And what's terribly annoying is when they don't give it to you from least to greatest. You've got to remember to put it in order. And then we like the middle because it is more resistant to extreme observations. And then be approximate. Where does the median happen? At what percent in life? The median happens at the what mark? At the 50% mark. So, in fact, sometimes the median is referred to as Q2. Q2 meaning the middle 50%. It's right in the middle. And then an important paragraph to note is the one below about comparing the mean and the median, and how the mean and the median are, if our graph is symmetric, they should be close together. And I like words, and words are great, but I like pictures too. So I'm going to draw a picture to represent these words, so you'll at least read this. If we say an average value, we're talking about the mean. If we say a typical value, we're talking about the median. And then I'm going to quickly draw an ugly skewed left, skewed right, and symmetric graph. Thanks. So I've got my graphs, and I want to consider the mean and the median in relation to these graphs. So with this graph, the median is going to be around here, whereas the mean is going to be a really much lower number because of that tail. Mean. The median is going to be up here if it was skewed to the right. The mean would be down here. And you can see how the mean's really not happening in the center where you think it should. But of course, if life was perfect, and we sure pray it is especially on the AP Stats test when it's a free response question. If life was perfect and our data was symmetric, the mean and the median should happen at the exact same spot, which of course means that the mean should be congruent to the median. So if you calculated both with a calculator or whatever, you should get the same number for both, or else you really just need to consider crying. Okay, are there any questions on that one? Now we get to the cool thing of the day. I think you already knew mean and median, but you didn't understand like why you want to choose median if it's skewed left or right. I hope those pictures helped. The interquartile range is the next thing we're going to talk about, which we call IQR. We call it the IQR. Now, I know you knew how to do the range, where you actually do the top observation minus the minimum observation. I know you know how to do that. I got that. We don't normally do that. That's too big of a spread. You remember the CUSS. That's too big of a spread. We want a more approximate spread. And like I was talking to Louise about, we want to know the middle 50% of data. So what we do is we consider the first quartile and the third quartile. Before we even go there, I should probably tell you words that they left off that are in your book, and you'll be like, Miss Compton never said those words. Oh, wait, you can't read a book. I forgot. Okay. It is recording. Right?
Yeah.
Okay.
Video.
Oh. Oh, true. Okay, percentiles are used to measure spread. You know, you're in the 90th percentile of your class. That means there are 90% of people are below you. So if I say the P percentile, like 90th percentile, that means P% of the data fall at or below, at or below it. And you already knew that because, again, you know your rank in life, and so you're like, oh, I'm in the 90th percentile, so 90% of people are below me right now in class rank or whatever. And percentiles are great, and eventually we'll get to probability. They will want you to calculate stuff using percentiles, like what is the probability of this happening, but it has to be in the 90th percentile. But for now, for us, we're going to stick to two very important percentiles, and that is going to be the lower 25% and then that upper 25%, which is the 75th percentile. So if we were to draw a box plot, which I know we haven't talked about a box plot yet, and I swear one day we'll get there. I can't do all the things at once. You understand that we would hope that like the 0% was down here, and the 25% was here, 50% in the middle, 75% almost to the top of that box, and then 100% right at the very top. If we have all these data points or all this data or whatever, when we want to know more about it, we actually really want to know about that middle 50%. So like I said, the 25th percentile is actually called Q1, 75th is actually called Q3. So when we're wanting to actually calculate with that middle 50%, we do Q3 minus Q1. Okay, so in fact, if you keep reading, it says, I'll come back to the calculate part. It says the interquartile range, which is what I'm calculating when I find that middle box. In fact, I'm probably going to draw a giant arrow to my middle box. Like, hey, look at your picture, Dupont. The interquartile range is the distance between Q3 and Q1, and it's a good measure of the spread. And here's why we use it, and here's why we don't use range. It is more resistant to outliers than the range. That makes perfect sense, because if we're cutting out the outliers, well, outliers would happen in that lower 25%. Outliers would happen in the upper 25%. So if we're cutting that out, of course we're cutting out the outliers. So of course we're getting a better look. Okay, and we use it to measure if it's skewed, you've got to use IQR. I get if it's symmetric that you can use a normal graph. But if it's skewed, you've got to use IQR. Okay, and then how to calculate. I think your gut would have told you how to do it anyway. You have to put everybody in order. You have to locate the median because that's the middle 50%. And then once you know where that middle is, you can cut it into fourths. And you're like, Miss Compton, I have no idea what on God's green earth you're saying, which is why we have an example. Yay! So let's see if we can get through this before the bell rings. Okay, make a stem plot of the data. Be sure to include the key. I think I'm going to put 0, 5, and at the lowest is 5. And then, number 1, I'm going to. And then 10, 1, 0, 1, 0, it happens again. 15 happens. 15 happens. 15, my God, there are a lot of 15s. 15. Does anyone not know what I'm doing? Okay, so if the number is 15, I put a 1 over here and a 5 over here. I'm just breaking it up. So now that I've done all the zeros and ones, I'm going to go to the 2s. So I see 2 zeros my next one, so I'm going to put a 2 here and a 0 here. I see 2 0 again, so I already have the 1, I got to put another 0. 2 0 again, I got to put another 0. 25, so I got to add a 5. Is that all the ones for that? I believe so. Then I go on to 3. Well, there's 30. 30 again. And then I don't see any more, so I go on to 4. I got 40. 40 again. 45. Then I have 60. 60. 65. And then my last one is 85. Okay, so I made a stem plot for the data, and would I have chosen to on my own? Probably not. Stem plot's not my go-to, but it is what it is. And then it said be sure to include a key. I don't care if your key is as simple as this. Key. 2 line 0 means 20 minutes. But somewhere on your paper, because I'm not psychic and neither are people who read your stuff, you have to explain what on earth you did. Are there any questions about part 1? Okay, well then part 2 says we need to find the median of the travel times. If we look back through the problem, they tell us how many data points do they give us? 20. So finding the median is not going to be so nice because it's not an odd number. So I've got to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to happen somewhere between these two. So it's happening between 20 and 25. So I need to average 20 and 25. What does that mean the median is? 22.5. Again, all I did was add 20 plus 25. Divide by 2. That's how I got 22.5. Now what sucks is that is the median value, but that median value actually never occurred. Okay, so we found it, yes, but we haven't interpreted the median value of the travel time. So how do we interpret that 22.5?
Roughly the amount of time it takes for New Yorkers to
What are they doing?
do things.
What are they doing?
Get to work.
Okay, so I wrote, and basically what he said, I said, typical person takes 22.5 minutes to commute to work. Okay, so the median wasn't that bad. So we did 1, we did 2, now we're on 3. And now we're supposed to find the interquartile range, which means we're going to need to find Q1 and Q3. Okay, so if there are 20 data points, that means half of it would be 10, right? So to find Q1, how many over do I need to count? 5, because half of 10 is 5. So I've got to count over 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So somewhere in here is Q1. Does everyone know how I figured out Q1? Again, if I knew that middle happened at 22.5. Then I know Q1 is somewhere in between that. And we'll come back to this tomorrow because I can already tell you're packing up on me and I really need you to pay attention to this part. If you want to be brave, you can go ahead and finish number 3. You should get 27.5. I'll go through the whole thing again tomorrow. If you did not finish your paper with your group, that's what you would want to work on. I'm hoping you use big boy sentences. I pray. I would like to make this an actual grade because